So this is my second year project, not part of the college syllabus, but I built it on my own. Uh, so this is called Intel 8085 Opcode converter. So Intel 8085, that is a microprocessor chip. So we we had a lab for this in our fourth sem. So there was a problem with the kits. So like an assembly program looks something like this: mov a comma b lxi h205a. So this is how an assembly program looks, but after you compile it, I guess. So for each chip there is a opcode sheet. There is an opcode sheet, uh, like this. So that maps every instruction an an opcode. What opcode does is it maps every instruction to a 1 byte uh, number, like this. These are hexadecimal. So 0 to 9 and then A to F. So the problem in the kits was that uh, we can't enter the program like this. It Actually we could enter it, but if we make a mistake, then we have to start from the very first line again. So the alternative was to convert it into these numbers, and these numbers we can write from any line onwards. So if we make a mistake, there's no need to go back to the first line and start. We can just resume from where we left off. So the problem was that we had to do this manually, this conversion process. We had a manual in which all these instructions and opcodes were written. So like so we spent half of the total time understanding the logic of the program, writing the program itself, like add A, add B, add C, these instructions, and then the other half of our time was spent converting it into these opcodes. Because in the program we have labels also, like this. So while converting it to opcode, we need to make sure that we need to take the memory address of the label, and then we need to insert it properly in the sequence of these opcode instructions. So that was a bit a little bit boring. So I made this just to help myself, so that I can focus just on writing this kind of programs to understand the logic and not worry about converting it into some other machine code to execute. So yeah, so I will clone it and set it up and show you how it works. So here dot means current directory. So here's the program now. It's main.py. My exe file is not shown here, no problem. So it doesn't require any other dependencies other than just the Python itself. So yeah, so here we have some basic validation just to check the input file that you supplied, whether it exists or not, and if the starting address is valid or not. So this entire program follows the hexadecimal number system. So no need to give the h suffix at the end of any number. So like here is sample program, 8-bit addition. Here is our program. We are using labels also here. So it just adds two numbers. So at this address there is one number, and at the address next to this there is another number. So we take those two numbers, we add them, and we store them in the next two addresses. So like 6000, there's one number, and at 6001 there's another number, and at 6002 uh, we are storing the result of adding the first two numbers, and at 6003 we are storing the carry, which will be 0 or 1. So that's how the sample program looks, very simple. And then just converting some hexadecimal to decimal and back. And then this is mainly file handling operations. So we have three files: the reference opcode sheet, and our input file, this thing, and then our output file, in which we will it will be created in the memory. We will write some stuff into it, and finally we will write it into the hard disk. So that's what some I have to store the labels also to insert them. So yeah, then we just read the program line by line and process it like that. So I'm not explaining the code in detail here. So it was in my second year, I wrote it by myself without using any AI. So let me show you. If I run this, it asks the program file name path. So I'll write 8-bit addition .txt. It requires the extension also. The 4-digit starting address of the program. Suppose it is of the program, not of where the data is stored. So this address is different from the address of the program. This is where our first number is stored, first input. Our program might be stored somewhere else. So I'll write 7000. It is generated. Enter once more to exit. So this is how it looks like. This is the address of the program where we want it to be. So 7000 onwards, and these are the opcodes. So like LXI H6000. So LXI H, this has 1 byte. This is a 1 byte. This LXI H takes 1 byte, and then the operand is 2 bytes. So 1 byte is 21. Operand is 6000. It is written in reverse order, 0060. So like this part is written, this byte is written first, then this byte. So after that 0E. 0E is MVIC. 00 is the operand, so it comes after that. So now, so so we also have labels like no carry. This is the label. To jump to this label, which is INXH. So, 0 E 00 7E. This is 7E, and this is 23. 23 is INXH. So INXH23 is found at a label. Here it is 23, the first INXH. Yeah, you can see. Yeah, 7000C. This is written in reverse order. At 7000C we have 23, which is INXH. And at 7009 we have, at 7008 we have D2, which says jump, and then next to operands are the address where to jump, so which is 7000C. So like it takes care of converting the labels also. So this you can just, in our college lab kits, this we can very easily type. Just go to address 7000 and start typing one by one, and then we can execute it. So there's an exe file also. If you double click on that, it will run it in the command prompt. So it's here. Yeah, it will also execute in the same way. So yeah, so one more thing is, so I wanted to practice this assembly uh, programming somewhere else also. So I found this site for it, Sim8085. Here, actually, this program I wrote after I started practicing on this.